All right, we're moving on to the next section now. 1.2, lines, circles, and parabolas. So this is all a review. Circles you might not have spent nearly as much time on as the other two, but overall, you've seen at least all of these things. The circles we'll focus on a little bit more. You're welcome. So first is the Cartesian plane. In the Cartesian plane, this is my x, these are my y's. Additionally, the positive y's are up on top, negative y's are on the bottom, positive x's are to the right, and negative x's are to the left. I bet you guys never knew that. If I have a point AB, now a member of the Tampa Bay Buccaneers, if I have a point AB, A is how far out I went on the X, and B is how far up I went on the Y, or down, depending on where the point is. Moving on from there, we have our quadrants. Quadrant 1 is everything that's up and to the right, and the X is positive, Y is positive. Quadrant 2 is everything that's up and to the left, the X is negative, Y is positive. Quadrant 3 is negative, negative, and it's down and left. And quadrant 4 is to the right and down. So it's a positive and a negative. Goes in a counterclockwise motion, starting with this quadrant. Quadrant 1, 2, 3, and 4. Increments in straight lines. Whenever a particle moves from one coordinate to another, the net changes are called the increments. So if x changes from x1 to x2, then the increment in x is delta x. That's what this triangle means. Delta x, or the change in x, is equal to x2 minus x1. I'm sure you guys have seen delta in physics, but that just means the change. So x2, delta x is x2 minus x1, or the distance between the points. If I'm following this coordinate,
Teachers, excuse the interruption.
if I'm looking at this coordinate 2, 5, and say something, well, it starts at 4, negative 3. So let's say it starts here and shoots up and to the left and ends at the point 2, 5. If something followed this path, then it went back 2 on the x. So it went from 4 to 2. In order to find that, that's our delta x. And that's just 2, because that's our second point, minus 4, which gives me negative 2. So delta x would be negative 2. It's the change in the x coordinate. So what would our change in y be then? Well, it's how our y changes. So it was originally at negative 3. Delta y is equal to negative, it's y2 minus y1. So it's going to be positive 5 minus a negative 3. 5 minus a negative 3 gives me a positive 8. So the change in x was negative 2, and the change in y was 8. Now this probably looks familiar to you because we've done change in x and change in y before. I guess I could have just scrolled down and saw that this was our problem here. So we found these two answers already. But our change in x and change in y, we see that with slope a lot. M is slope. The constant m is the slope of a non-vertical line defined by the change in y divided by the change in x, or the increments for y divided by the increments for x. So now if we have to find the slopes between the points 9, 4, and 3, 2, I hope at this point we can find what slope is. we do y2 minus y1, which is 2 minus 4, over x2 minus x1, which is 3 minus 9. 2 minus 4 gives me negative 2. 3 minus 9 is negative 6. Negative 2 over negative 6 is a positive 1/3. That's my slope of the line. Again, I hope we can accomplish slope by now. That's an Algebra 1 concept. Also from Algebra 1, we have the point-slope equation. The equation y equals y1 plus the slope times x minus x1. Now, you might have seen point-slope like this before. Y minus y1 equals slope times x minus x1. That's the more traditional form of point-slope. This one, they just got y by itself already. So basically, if I have a point x1 and y1, then this is the equation of a line that goes through that point and has a slope of m. We also have the equation y equals mx plus b. That should be familiar to you as well. That is slope-intercept equation of a line. That's whenever we have our slope m and the y-intercept, or where it crosses the y-axis, and that's the point B. So let's find the slope and y-intercept of this line. Well, the easiest way to do that is going to be to get y by itself. So let's subtract the 8x over first. 5y equals negative 8x plus 20. Then we just divide by 5. It gives me y equals negative 8/5 x. Do not turn that into a decimal. Plus 20 divided by 5. 20 divided by 5 is 4. There's my equation in slope-intercept form. B, or my y-intercept, is 4. And m is my slope, and that's negative 8 over 5. And that's all we were looking for. This might be a little bit of a newer, or not a newer concept. The circles part might be new to you. But when we're looking at distance and circles in the plane, the distance between points in the plane is calculated with a formula that comes from the Pythagorean theorem. You might remember that when we're looking at triangles, we have the Pythagorean theorem if it's a right triangle. And that theorem told us x squared plus y squared, or even better, this is most likely how you saw it, a squared plus b squared equals c squared. So that's how we would see the Pythagorean theorem. Our distance formula is just the Pythagorean theorem, all rolled together. It's the change in x squared, it's this change, plus the change in y squared, which is this change, and it's the square root of all of it to get us back to c instead of c squared. So you can see how that would help us find the distance of this line. I'm taking this distance squared plus this distance squared, and that'll find this distance squared. Then take the square root. Brings me right back to the distance. Shout out to Russell for teaching us this 2 years ago. He's like the greatest teacher ever. Yes, I did teach you the distance formula in geometry. Also taught you the Pythagorean theorem in geometry. So you're welcome. I knew someday you would go on to greatness like calculus. And I said, You know what? I bet I'm going to be teaching them that too. Because I bet Malik's going to be the assistant principal by then. I'm a genius. If you want to know tomorrow's lottery numbers, let me know. I'll be able to tell you those too. So let's calculate the distance between these 2 points. We start by finding our change in x and our change in y. So delta x would be 3 minus -1, which would give me 4. But Russell, how do I know that this is the second point and this is the first point? What if it's backwards? That's a great question. Even if it's backwards, delta x would be -1 minus 3, which would give me -4. You're going to find out why that doesn't matter. Delta y, 4 minus 2, which is 2. Or it could have been 2 minus 4, which is -2. If we go back to our formula, you'll remember that we're looking at the square root of delta x squared. So that would be the square root of 4 squared plus the square root of 2 squared. Or, if we were using these ones, square root of -4 squared plus -2 squared. 4 squared is 16, 2 squared is 20. We have the square, 2 squared is 4, 16 plus 4 is 20. I'm already just jumping ahead over here. Over here, if I take the square root or the negative and square it, it gives me a positive anyways. So it's still 16 plus 4, which is the square root of 20. Think of perfect squares that multiply to give us 20. That would be 4 and 5. Don't even have to keep doing this right side. I mean, we all know it's going to be the same. Square root of 4 is 2, so that comes out. And there is no square root of 5, so it stays inside. Our answer for this distance is 2 times the square root of 5. You should remember how to do that. If you don't, practice up on it a little bit. All right, that's where we're going to leave off for today. Tomorrow we're going to pick up right back here and start with circles. This is where it can get a little trickier, but not too bad.